Hello and welcome to today's session on Excel tips, tricks, and techniques. We're going to be going over creating rack elevations from a server inventory list in Excel. So, we'll go over why is it we're doing this. The purpose for creating rack elevations is so we can get a visual representation of our data, which is in a list format within Excel, but at least show it from a side-by-side rack view and row view. And then as an expected result, we want to see a picture of that. So not only will we just see the list, we actually see a visual representation so we know how much room we have left in a rack, how many you are taking up in that rack. And then there are some assumptions that we're going to go through. And on the assumption side, in order for this to work, you have to be consistent with your data. So the lists and the columns of how you're tracking your inventory need to be consistent and need to be thinking about some of the naming conventions on sorting and how things work, as well as if the information is not accurate, then garbage in, garbage out. Okay, so in order to do this, we're going to be using certain functions. Our key function that we'll use is VLOOKUP. So that gives us a list lookup of things in another table, and it will return a value based on the value of what we have in that list. And then concatenate from a formatting perspective, as well as is_NA. So we check and validate whether any reference or something that's coming back as a not found, we can make it not show that #ref or unfound number. So we can actually show that that's not going to be representing our visual representation poorly. We'll also look at multiple sheet reference. So we're going to be using VLOOKUP to look at sheets and other tabs, as well as pivot tables. We're going to show a view of this from a pivot table point of view. You can show rack elevations just by using pivot tables, but it does not show you side-by-side racks. Okay, so now let's go ahead and look at our hands-on sample. Okay, so let's go ahead and get into the actual elevations that we're going to create with Excel. So what I like to do in general is if we look at a standard results, I look at what do we want to get out of this, how are we going to create this. So I'll either whiteboard this or come up with what is the mindset of what we're going to produce. So in that process, I know I have rack units going from the height of the rack all the way down to number 1 on the left-hand side. And then I have my racks within a row. So I have my first rack, second rack, third rack, and so on. And the next thing I've done is I've created a RU number. So what is the height of the device that would be in this rack? So we're going to show the device that sits in this particular position in the rack, and that rack is based upon a certain location. So I'm in a building, I am in a floor in a room, and I'm on a particular row. I'm either on the front side of the rack or the back side of the rack. So these are some what I call keys. So the combination of all 4 of these items plus the U that it's sitting in the rack will decide what device lives there, and that's how I have to display. So that helps me understand, well, what is it that I'm going to show there and what formulas do I need to use. So if I go back to my devices, this is all the devices that I have in my inventory. So knowing that I need the key information that's about the building location, it's about the floor and the room, the row, the front or back of the rack. I know that those are columns that I'm going to track. That's information that I'm going to track. I've created a first column here that will concatenate that same information in my columns into one row. So this becomes my key. Everything that I search for on the other rack is going to basically search on this column. And then the result will be whatever the column number I want. And that's part of the VLOOKUP function. Okay, so I want to go to my elevations, and instead of doing the back, every one of these cells is doing a lookup combining that information, which is the building, the room, the row, the rack, the front or the back, as well as the U, finding it in that full list of items and returning the name and the device height. So we can see that it's found a sparsity of devices in this back side. But if I look in the front side, obviously there are many more devices. Okay, but it's basically purely data driven. It's filtering based off of building out that key value. I can change the building, I can change the floor. So when I change the building, it doesn't have the same room and floor, right? So if I go back to building 2, location 2, building 4, and let's say I'm going to change, instead of row A, we're going to go to row C. Things change quite a bit. And if I zoom out a little bit, you can see that they all go to rack 11, but there's different availability. So this gives me a quick visual, and this is the power of doing this in Excel. I'm not necessarily in my decent product or whatever that end result might be. I can do some future state playing around with devices without actually having to input them into anything. So it just gives me a quick view based on an inventory list that I have of all my devices. Okay, so this is the device list that we created. Now we get into why it's important to have consistent data. So as you're going through here, your device name will be whatever the device name is, your standards. So you have a standard for that. The building can be a data center name. It might be a building number. You might have multiple columns for this, which is fine. If you do that, you just need to make sure you're concatenating multiple fields, and then you do the same thing on your lookups, right? You just have additional lookups here, and then when you drill down to how do I find that device, if you look up the top here, that's a pretty big formula. And I'll drop this down so you can see how large this formula is. When I highlight it, you can see the items that are included in the formula, the cells that are included in the formula. So obviously the things I'm looking for that are concatenated for me, well, I'm using that same concatenate function in the formula itself. So that allows me, and as I'm seeing this right here, I could actually improve upon speed and space if I were to go ahead and just concatenate that here to this cell and then always look at this cell instead of having to do that within the formula up there, which means that my spreadsheet's going to be a smaller size once I save it. It's always constant improvement. So you can always implement that if you actually do this on your own. Okay, so back to the formula itself. What this does is it's basically doing a VLOOKUP. Regardless of what the concatenate does, it says look up the location that I am saying that I want to see plus the current RU value of this particular rack in my all devices. Find that item and return the device name. And it does the same thing for the device height. That's really what this function is doing. Now the key is if you want to look at for the lookup, I want to look up whatever that value is, which is the concatenation of these 4 items plus this RU location, right? And it's going to look it up in this table, which is basically my first table in my All Devices tab, and it's going to return the 14th column. Okay, so the 14th column will get returned. And then it does it again, the second VLOOKUP, because this first VLOOKUP is done as a subset of the isNA function. So that says that, okay, go ahead and do the VLOOKUP. Tell me if something is found or not. If nothing is found, then just return a space. I don't want a pound sign ref or a hashtag response here. I want it to just be blank so my visual looks better. So if for some reason it comes back and it did find it, then it redoes the same lookup and returns the value that is in the 14th column. Okay, so let's look at that physically. So it finds that same item here. It's the concatenation of all those values. It found it here. If it returned true, then it's going to return, this is the 3rd column, which is the device name, and the 14th column is going to be the RU number right here. So this is the 14th column. So keep that in mind as you're using VLOOKUP. It's saying look up a value into a table and return the X number of columns of that table. And we're doing it twice. We're doing it once for the number 3. This guy's doing it in the 3rd. And then this guy's doing it in the 14th. And that's really basically how we build rack elevations using the data that we have from a list right here. Now, I mentioned earlier that you can do this with pivot tables. So if you create a pivot table, and we're using pivot tables throughout here, so we have stats that show us number of power connections, number of copper cables, fiber cables. As long as your device has all that column information, it will roll that up at a standard level, whether it's the room, whether it's the building, a location, a data center, down to the rack that it lives in, all the way down to the appliance itself, right? Or by the type of appliance. And you control this with your pivot tables. So if I were to do an elevation that was using pivot tables, I don't have the niceness of seeing the whole row at once, side by side, but I can on an individual basis vertically show all of the items that are, as this example shows, location 2, building 4, room 10-101, row A, the back side and the front side. If I were to expand this, my front side has 176 devices. Okay. I also know the number of cables that go to the front side of that row. There's 45 and the 172 U in that particular area. If I drop down to something that has quite a bit more, so let's go for, actually 176 is the highest amount. This is down to the rack. So on the front side of that row, I have rack 1 through 11. And this is, again, the numbers. So as an example, my rack 1 has 16 devices in it. It takes up a total of 15U out of my 42U total. Right? So I know they're not taking it up. So if I want to see what those devices are, you notice this counts down, so I can see this is representative of the height and how I would look at it in the rack. However, I don't see the separation between the devices, and I don't see if there are any items within those. One big plus you have to this is if there are duplicates. So we had mentioned before, like this color, I've got a conditional format that will show duplicates in here. I also created an extra column that would count the number of times I see those duplicates. Now, elevations, in theory, you shouldn't have that. However, because we're tracking at a specific view, if you have blades, as an example, in a rack, and they're in an enclosure, well, the enclosure is actually taking up the space. The blades live within the enclosure. So in that scenario, you'll see something with like 16. Yeah, so these are 16 blades that live within the same enclosure. The enclosure in and of itself is the one that will be the device name that shows up on my elevations. These guys will not show up on the elevations because these are mostly 16.1 or whatever the rack elevation is. It'll be 0.1, 2, or 3, and they have no height in their device. Right? They're not taking up any U. The enclosure itself is taking up that U. So if we go back to here, this gives us a visual representation of that individual rack. If I were to expand that whole row, obviously we've got to scroll up and down. So it's not as nice as the elevations that we see side by side. However, it is very functional for us to be able to see that information. And we can see a number of power supplies, all kinds of different things that pivot tables allow us to do. All right. So the other key that is important for this is basically data driven. So within this one sheet, we're always dependent upon what information is in here. And you'll notice I have drop down lists. That's important to make sure that I don't mistype information and I'm not able to find information in the other sheet. So this drop-down list is actually a format that we can see based upon each of the columns. So I have a lookup table that drives to each of the different building locations, as well as the owners of the devices and the rooms that they can be in and models. So whenever I add a device, it's going to have to fall within these, as well as from my reporting point of view, I can pick from those same lists. That just gives me consistency, make sure I'm not accidentally overwriting or putting the wrong information and missing something. But since it is data driven, it does calculate. It's accurate as my information is in my lists. Okay. Well, that brings us to a conclusion for our creating rack elevations using Excel. Please feel free to share, comment, and hopefully like this presentation of Excel tips, tricks, and techniques. Until next time.